This is a video in the trigonometry topic of the Pure Maths 1 course, and it covers the sine rule. So the sine rule is used for finding sides and angles of triangles which are not right angled. Sine rule is used when we know two sides, say this one and this one here, and one of the three angles, like that, where the angle is opposite to one of the two sides that we know, so either this one here or this one here down there. We use the sine rule then to find the other side and the other two angles. Or if we know one side, say that one, and two angles, say that one and that one. Of course, if we know two angles, we will also know the third angle, because three angles of a triangle would add up to 180. So the sine rule is used to find all the unknown sides and angles of either of these triangles. So if we take a triangle then, and we label it like this, the vertices, the corners, are labelled with capital letters, and they also will represent the angles, the capital letters, and the sides opposite each letter, each angle, is labelled with a lowercase letter. So that side is side A, little a, because it's opposite the angle A. This is B, opposite the angle B, and this is C. Now, supposing we draw a line from B to AC, so it cuts the line AC at right angles like that. And we'll let the length of this line, this perpendicular from B to AC, have length H. This then splits our triangle ABC into two right-angled triangles. This one be BC to the line, and we've got AB including that line as well. So in a right-angled triangle, we know that the sine of an angle is opposite over the hypotenuse. So in this triangle here on the left, we can say that sine A equals the opposite, which is H, over the hypotenuse, which is C, and also sine on the other right angled triangle, sine C equals the opposite H over the hypotenuse A. The first of these equations here, we can multiply both sides by C, and we get H equals C sine A, and this one is H equals A sine C. So we can see that H is both C sine A and H is A sine C, so we have C sine A then equals A sine C, and if we could divide through by A and C, we can see that sine A over A, divide both sides by A, equals sine C over C. So we have sine A over A equals sine C over C. Now, there was nothing special about drawing the vertical line from B to AC. That was just a line which went from the B perpendicular to AC. Instead, we could draw one from A to BC, like that. And that also cuts the triangle into two right-angled triangles. and we can do the same thing again. And h is now this length here. So we can say that sine b equals h here in this triangle there. The hypotenuse is c, so it's h over c. And sine c equals h over b. So just like before, we can say that h here is c sine b, and h here is b sine c. And so these two must be equal, they're both equal to h. C sine b is equal to b sine c, and dividing through both sides by cb, we have sine b over b equals sine c over c. And so sine a over a equals sine c over c, sine b over b is sine c over c, so all three must be equal, and we have sine a over a equals sine b over b equals sine c over c. So there are three equations there. Sine a over a equals sine b over b. Second, sine b over b equals sine c over c. And thirdly, we have sine a over a equals sine c over c. Also, we can turn this equation upside down and write it a over sine a equals b over sine b equals c over sine c. So the three equations can be written in that form as well. Now we want to use this rule to find the side BC in this triangle here. Here we know the side AB and the two angles A 35 degrees and C 76 degrees. Of course, this means we would know B, because B would be 180 degrees minus 35 minus, which is 69 degrees. Now we want to find the side BC. So using the second of the set of equations, the A over sine A, B over sine B, C over sine C, we can say that BC divided by the sine of the opposite angle, which is the 35, sine A, equals, and then we have we have the angle C, 76 degrees, and the opposite side C, 9, so that would equal 9 over sine of 76 degrees. And then multiplying both sides by sine 35, we'll have BC equals 9 over sine 76 degrees times sine 35 degrees, and using the calculator that will equal 5.32 centimetres, and the sides are in centimetres, to three significant figures. Suppose instead we have a triangle where we have two sides and an angle which is opposite to one of the sides we know. This is instead of having, if we had this angle here, the angle B, and the two sides, then we wouldn't be able to use the sine rule. This side here, this angle here, B, is between the two sides, and the opposite of B we don't know. And in order to solve a triangle with those those values, the two sides and the included angle, we need something called the cosine rule, which we'll do in a later video. But in this case, we have two sides and a side which is opposite to the one on the known sides, and we want to find the angles, the other two angles, B and C. So we want to find an angles, so it is better to use the second form, where we have the angles, the sign of the angles on top of the fractions, and we can say sine of 63 over the opposite 11 equals sine of C equals the opposite side 8. So multiplying through by 8, we'll have sine C equal 8 sine 63 divided by 11, which equals 0.648 on the calculator, and so C is equal to the angle whose sine is 0.648, or arc sine 0.648, and from the calculator that is 40.4 degrees. To find angle B, we could use the fact that three angles of a triangle add up to 180, so B equals 180 minus 63 minus 40.4, which will come to 76.6 degrees, both to three significant figures. Now pause the video and try this problem for yourself. When you have finished it, restart the video and see the solution. So first draw a triangle ABC and put in the information we have in the question. Angle A is 58, angle B is 47, and the side AB is 14, and we want to find angle C and the other two sides BC and AC, and so we will completely have solved the triangle. We'll have all three sides and all three angles when we've done that. Now we've got two angles, so to find angle C we need to use the fact that three angles of a triangle add up to 180, so C is 180 minus 58 minus 47, which is 75 degrees. So we can put that on the diagram, different colour, 75 degrees. And then to find BC, we use the sine rule. We want to find the side, so put the sides on the top of the fractions. BC over sine of the opposite angle 58 is equal to, and we have the side AB is 14 over the sine of 75 degrees. So multiplying through by sine 58, we have BC is 14 sine 58 over sine 75. And using the calculator, that equals 12.3 centimeters. To find AC, we do the same thing, but we have AC divided by sine 47 sine 47 degrees equals, again, 14 over sine 75, multiplying by sine 47, we'll have AC equals 14 sine 47 divided by sine 75, which gives us 10.6 centimetres to 3 significant figures. Okay, now return to Study Smart, where you will be able to practice with some more questions that you can download.